Transformations of quadratic and absolute value functions. So first we need to talk about the parent function, which is the starting point of any transformation. So the parent function equation is f of x equals x squared. So in this case, the vertex would be at 0, 0, because h would be 0 and k would be 0. So remember that when we're finding h and k in vertex form, we would use the opposite sign for h and keep the same sign for k. So to graph the parent function where h is 0 and k is 0, the vertex is at 0, 0. So the first critical point in the parent function would be 0, 0, the vertex. Then we would have points at, if you made a table, you would have points at, negative 1, 1, 1, 1, negative 2, 4, and 2, 4. So you kind of want to learn the pattern of your basic quadratic function. Negative 2, 4, negative 1, 1, 2, 4, and 1, 1. So those are going to be your critical points for the parent function. Again, this is your starting point before any transformations happen. Let's talk about absolute value. The parent function would be f of x equals the absolute value of x, where, again, h is 0 and k is 0. So my vertex would be at the origin 0, 0. Now in an absolute value function, if you made a table, your other 4 points would be these. So negative 2, 2, negative 1, 1, 2, 2, and 1, 1. That's going to be your starting point for any before any transformations. So transformations of a function, we are looking for h and k for horizontal and vertical shift. When k is positive, the graph moves up. And when k is negative, the graph moves down. Then when we have h, when h is positive, the graph moves right. Now remember, when h is positive, because we use the opposite sign, in the equation you're going to see x minus h. Because h is positive when you see x minus h in the equation. And when h is negative, the graph moves to the left. But remember, think of it in the opposite way, because in the equation, you're going to see x plus h. Okay. For a, when a is positive, now remember, we're thinking up here in vertex form. This is a, what's in front of the brackets or what's in front of the parentheses. When a is positive, f of x keeps its orientation. When A is negative, the graph is reflected over the x-axis. And what I mean by reflected is that if your parent function looks like this, and then we transform it to where A is negative, it's going to reflect over the x-axis and be pointing down. When A is greater than 1, then we have what's called vertical stretch. The shape gets narrow, closer to the y-axis. And when A is smaller than, I would like to say, the absolute value of 1, or let's say that when A is a fraction, then the graph has vertical compression. It gets wider. Closer to the x-axis. Okay, so we're going to look at some equations and write what the transformation is. The first thing you have to do when you are telling me what the transformation is identify what the parent function was. So in this case, we would say that because we see this exponent here, we know that the parent function was f of x equals x squared, and the transformations are as follows. This minus 3 tells you that it shifted 3 units right. And this minus 3, which is k, says it shifts 3 units down. Now for number 2, we have a negative here. So actually first let's identify the parent function. The parent function was f of x equals x squared. We're going to say it reflected across the x-axis. Then we have the 2 here, which is vertical stretched. So we're going to say it's stretched by 2. Shifted 3 units right. And 2 units up. Okay, for number 3, it's giving us the description. Let's write the equation. So the parent function is f of x equals x squared. So I know I can write f of x equals here. Now this says it's reflected over the x-axis, so I know this is going to have a negative. And the next transformation is shifted left 3 units. So I'm going to write x plus 3. And then for shifted up 3 units, we have a plus 3 outside the parentheses after the exponent. Okay, number 4. This is going to be an absolute value function. So the parent function would have been f of x equals the absolute value of x. And the transformations are reflected, shifted 1 unit to the right, and 1 unit up. Number 5, this is another absolute value function. So f of x equals the absolute value of x. And the transformations are shifting left 1 unit, and down 4 units. Now here's a description, and let's write the equation. So the parent function is f of x equals the absolute value of x. So I know I'm going to have absolute value brackets. The first transformation is shifted right 2 units. So inside my brackets, I'm going to write x minus 2. And shifted down 3 units means I'll have minus 3 after the absolute value brackets. So that is what you're going to be doing on today's practice. You're going to be describing a transformation based on the equation or writing an equation based on the described transformation.